I think we are as good as we're going to get right now. If you will, a little bit about me. I'm a person who can talk for hours and days on very specific topics. Let's put it that way. Go ahead, I double dog dare you. Now, as far as some learning objectives, really, I just want to show you some different practices. Maybe you learn a few things with Excel that you haven't done previously. The goal is to really drive to, say, root cause or get to the point where you can make changes and impact outcomes. A lot of times we use software in the Six Sigma world, and I wanted to really explore what we could do with a real data set, the tools that are available to most of us. So that's the idea. So why do we do this stuff, right? I think of this as the whiter teeth and fresher breath slide, right? And at the end of the day, it's to monitor and improve the health of your process. That's why we do these things, right? So that we can look ahead rather than just seeing exactly what's directly in front of us. And so why chart your data? After all, we've got all this fancy statistical software that does all kinds of cool things. Yes, I agree. However, if you will, Anscombe's quartet is this data set where we've got 4 different sets of data, and you can go look it up. It's in Wikipedia. You can see the actual values, and they all have the same summary statistics out to 2 decimal places. Okay. And if you didn't graph them, you'd think they were the same thing. So check it out and keep that in mind the next time somebody talks about the averages. And anybody who spends much time with me will tell you that I particularly loathe averages, right? And in fact, one of the things that we say in the Six Sigma world is, if you hold someone's feet in the fire and their head in the freezer, then on average, they're comfortable. All right, so here's what you don't want to do, folks. I mean, after all, I think somebody put this chart together, this actual chart. I think they put it together because they could, because it was the quickest way to get to a chart. So don't chart data just because you have it. Make sure it makes sense. And here, at the end of the day, here's your litmus test. Ask somebody, are we winning or losing based on this chart? And, then you can decide. But I will tell you, the one thing that drives me crazy is when people use bar charts to represent time. And it's because the bar charts trick your eye. Right, the important part is the part that's up here, but what we see is the solidity of the bar, all that color, and we miss those trends. So don't use bar charts to represent time. Okay, so here's a way to remember the things that you need to do for good data analysis, no matter what your software package. Okay, you're using the data, download, arrange, transform, and then analyze. And we'll step through each one of these with our data set. And I'll show you some tools, the charts that we mentioned, and you'll see the results on the data set. So hopefully it'll be pretty interesting. So here, if you will, some questions that are going to help you to understand what is the purpose or the outcome of each one of these steps here, right? So here's my suggestion. It's always a good idea to create a problem statement and objective with a group that everybody agrees to. Then you can use data. You can use that problem statement and objective as the litmus test. Hey, is this an action or is this data that's going to help us further our goal? If it's not, then let's ignore it. And if it is, then let's work on it. That's how we stay on scope. That's one of the ways. The other way is to use a SciPoc as well. But anyway, so here's the data set. And this is an actual client data set. It was inspection failures. So in the situation, it's very high tech. The operator takes 2 optics, lens 1 and lens 2, bonds them together, and then checks for defects. Pretty straightforward. So here's data set. It went out to AA, so it had about 27 columns. And if you take a look at some of the close-up, you can see initial inspection said, all right, it's good database format. Every row is a record, every column is a field. There's no merged or skipped cells. So yay, let's go. So, and here's what that looks like as far as a good data set for analysis. So there's some real issues here. I mean, for instance, here's just one of them. Operators fill in data. And so all of these different versions of the same issue make analysis difficult, just for instance. So the unsung part, the part they don't show you on television about being a data detective is Somebody's got to go through and clean all of these up. And we'll talk a little bit about how to make it better moving forward. But here's my suggestion. Let a few people that do the job fill out the form and then talk about how they decide what to put in or what to blame. You know, when they're, sorry, what reason code to use. And then I think that'll spark an interesting conversation. Here are some of the things that you should be aware of when it comes to data, right? And most of what you see is summarized already. And the problem is it's got the analyst's biases in it. You don't necessarily know what's included in that data set or what was excluded. And so you really want to start at that raw level. So here's some warning signs if you're going to go off the wrong path, right? Pretty much any report you download is already automatically a summary, especially if it uses the title summary in the title. If it has averages, ranges, or ratios, whether it's units per person or you know, acres per fortnight of field plowed, whatever you're trying to measure, if it's ratios, then it's already automatically filtered. So what you want to do is get the raw data, transaction level data, or defect or production level data, right? And I know people love Power BI. Yeah, it really is cool. I agree. It's not raw data. So, you know, phone a friend if you need help getting your ERP data. But whatever you do, try to start there. So let's talk for a moment about histograms, right? So what are histograms? It's really charting the data and the frequency diagrams, some people call them, right? But we're looking at how often certain values come up and group it in buckets. So we're looking for shapes. Many people are familiar with the bell-shaped curve. That's what we call a normal distribution because we see that in a lot of different areas. Okay, non-normal distributions are skewed. They're not that bell-shaped, and usually it's an indicator of two different processes that we're mixing that we shouldn't be. Maybe it's the results of two different shifts or two different lines or two different call centers. You know, could be different performance there. You know, if you were managing retail operations, you might have a difference between the daytime and the nighttime or between the St. Louis and the New York branch. You might see those things and identify the need to go further with a histogram. Okay, now, so here is a histogram for our data set, and what I looked at was for the days to completion. And so here you can see the interpretation is that many issues were closed within 10 days, but some, the long tail, means that some took a lot longer. And so histograms allow us to see it. So now let's talk about the D part of the data model. Okay, so make sure you have access and then extract data from it. Make sure that you name the thing properly and save it where you can find it again because you may have to refer to it. Now, people often ask, how much data should I get named? And the short answer is start with the most recent week, month, or quarter, depending on how hard it is to get. You know, as for example, I may not care what your data was like before COVID, for instance, before 2020, because it may not be the basis for comparison now. Usually it's not. So I don't usually need to go back too far. 3 to 6 months is okay. Year to date is great if it's easy. And you have to ask yourself, you know, is it a meaningful comparison? Here you go. So basically with a pivot table, what we're trying to do is we can summarize many ways, obviously with a couple of clicks. You know, people who spend the time to understand pivot tables really are like data ninjas. So, and there are some people out there, you know who you are. I'm in awe of you guys. Anyway, it makes it easy to create a pivot table. Now, people might talk about pivot charts. That's true, but I don't really know how to use them. When you try to do things within pivot tables, it gets a little weird. I copy the data out and then use it elsewhere. So time is a factor that very often is ignored. For some reason, we just don't think to chart our progress from week to week so that we can tell, are we getting better? Are we getting worse? Or are we kind of bouncing around some average, just staying the same? You know, some weeks are a little better than others. So that's what we're looking for, patterns or trends, shifts and drifts. SPC charts are merely time series plots or run charts with some added features. And those added features allow you to know when to take action and when it's just noise. So that's another fascinating topic on its own. So from our data set, we looked at failures over time. So In this case, we looked at it by weeks. We had a data set that covered from January 2022 through October 2023. So we grouped it by week and realized that failures occur every so often, not every week. It's not every day. It's periodic. So again, the situation is the operator takes two optics, bonds them together, and then checks for defects. Very simple. So where are defects coming from? Well, that's where we need to dig a little deeper. And so if you take a look, the next tool we want to use was a Pareto chart. Where are objects coming from? Where are defects coming from? So Pareto charts show ranking. And so there's a 19th century economist, Vilfredo Pareto, who was studying income distributions in Italy. He realized that 20% of the population held 80% of the wealth. And when he looked further at that 20%, he realized that actually things are fractal, and that 20% of Italians, of them, 20% held 80% of the wealth that they had. So it's pretty interesting, actually, when you start looking at some of this. And he didn't develop Pareto charts, but they were named in his honor. So, if you will, obviously it lets us know which areas to work on first. And we usually look at this cumulative line, and we usually look for the 80%. So we'll take a look and see what we need to focus on. So from our data set, again, we've got the two optics, L1 and L2. And so we've got different defect codes. So what I did was arranged them, sorted them, and then looked at them. Well, the first three were contamination. So, okay, while chips and bonding issues can be an issue, contamination was clearly the big dog in the room. And in fact, it does account for about 80% of the issues, right? We find this 80-20 rule a lot. So as it turns out, the one big thing that's bigger than twice as big as everything else is this L1, L2 assembly. So it's not that L1 lens is bad. It's not that L2 lens is bad. It's that when they bond them together, that's where the defect's coming from. So we've ruled out the internal suppliers of this process in terms of finding the issue. So we're getting closer, right? So now let's arrange the data for further use. And if you will, there's a lot of problems with data when you look at it. It could be duplicate entries. It's, I showed you when there's handwritten data. Sometimes people include order numbers for traceability. Sometimes they don't. Sometimes they call it whatever they want. So, you want to have drop downs where possible and try to eliminate some of these issues. Make sure that things are clear and consistent and the dates are in the right format. The unsung part of a data detective is that hand-to-hand combat, row by row of a spreadsheet, right? You guys know what it's like. And if you will, ChatGPT or DALL-E 3 specifically helped me with this image. And what she's saying is, but how do we know the data is correct? So that's something to keep in mind, after all, right? I mean, we've got data. We're working on bludgeoning it in the right format. How do we even know that it's right in the first place? And we can talk a little bit about that. So my pro tip here is one, believe me, I've learned this one the hard way, and I'm trying to avoid you from doing it too. You did save a copy of the original data, so you don't have to go back and ask for another download, right? And when you transform the data, it's really all about pivot tables. And again, anytime you spend on pivot tables, well worth it. You can do different things here, but this might be calculating elapsed days or looking at certain percentages or whatever you're trying to do. Pivot tables are going to make it easy. Okay, and then let's go ahead and analyze some of the data. And here ChatGPT helped me out with these colorful charts. I asked for colorful charts, and I got exactly what I asked for. So box plots show us differences, right? I mean, technically it's continuous output with categorical inputs. But, in this case, if we're looking at a filling operation, we have different lines for different flavors. So we could see how consistent each filling operation is. So the thing about box plots is, once you get used to them, you don't think about it. When you're new to them, you think bigger is better, but smaller is better. I think of the box plot, the box, as being the area. When I'm throwing darts, that's the area that I'm hitting. So smaller boxes are more consistent. That's better. Larger boxes mean that I've had a few too many adult beverages and probably should put down the darts. So that's what we're looking for, though, is this idea of how consistent are we and where are we centered around. So that helps us. So our data was not great for box plotting, but hey, I was able to box plot the quantities of reason codes that we had. And it turns out, sure enough, that L1, L2 is the most variability. Sparklines, though, are little charts that you can put inside the cell of a spreadsheet, right? They're very low impact. They're easy to do. And the idea is that you can show trends. And there are different styles of sparklines. The one that I always use really is the line sparkline, what they call the regular sparkline. But there are different varieties here, including the win-loss chart, which is great if you're looking at pass-fail information or pass reject. If you think that it's related to, say, equipment like a valve, maybe that gets weak, or a capacitor that discharges over time, maybe. A win-loss chart might help you seeing that. And it's just an easy way of seeing trends of data, right? Because inspection is when we look at a whole long line of meetings. You can see this in management update meetings. We look at a spreadsheet or a report, it's a whole long line of numbers, and we sometimes with our finger, we go down the line and try and make meaning of it. What are the trends and what's big, what's not? Very difficult to do. Use a sparkline instead. So from our data, here's the sparkline here, right? I created this failure count already, right? You had seen that. I turned it into a run chart now. And then what I did was isolated the data and then took and created a sparkline at it. So you can see it's the same shape. And even though a chart may be represented in a cell, it's still very legible. At least you can see where the highs and lows are and can zero in on the data themselves. So, I mean, here's some of the issue, right? So L1 defect versus L1, L2 contamination versus L1, L, you know what I mean? It's spelled differently. It's worded differently. This is L1, L2 lens contamination. So what you have to do really in this case is you go back to home and then you really just sort and try and bring everything up. And then I'll just take one, copy it, and then just copy down using the Control-C, Control-V. So, I mean, I'll do something along those lines. On the insert ribbon, I think it's called, is a pivot table. And how many people actually knew that? Not nearly enough of us. I'm just going to say that out loud. So then, it's pretty good at this point. We could do things like look at general status and then even see if we wanted to how many are complete and how many are processing there, right? Did you see that? Just in a blink or two or a couple of clicks, I was able to just do that. And that's the point. You can change the stuff around. Not very smart. Let's bring like cause code ID and here again, now I can do this and then go back and sort and filter, go high to low. And you can imagine now that what I'd have to do actually is copy this out, go to paste, and then if you go to insert, here's where I'll slow down a little bit. I'll put in titles. So I think this was area, and I'm just going to say count. Now what you do is you go to insert, and then if you go over here, they're all in here. If you go to recommended charts, you can see everything, but generally speaking, I don't know how well you can see this. I can't seem to zoom in on that ribbon, but if you click there, you can get the histograms or Pareto charts. So in this case, I can create a Pareto chart. I can then change the title, so Pareto, and that's how I create charts, right? They're all there. If you go to insert, and then here, these are run charts. And there's different styles. I don't use the fancy ones, honestly. I use run charts, 2D. I use histograms, Pareto charts, and for the purposes of this webinar, I started using box plots, but I'm going to plan on dropping that practice pretty quickly. Sparklines, what's interesting is what you have to do is you have to take a row of numbers. Let me see. I thought I had done this before. Okay, there. So here, let's just take these. And what I'm going to do then is I'm going to insert, and then here were charts. If you go over here to more sparklines, right? It's probably been in front of you the whole time. So I go pick that. Now, I didn't pick my location range, but it did pick up the data. So I'll just say I want it there, and then click OK. And now if you take a look, you can see at the bottom, I've got my sparkline. And it's that easy. So think about it. If you've got a lot of tables, you can just put these Sparklines in and just make it that much easier to read your reports. Anyway, so what can you do with this stuff? Build a Power BI suite that really helps people. Here's the point. Whatever software you use, remember this whole data approach. Go raw, get your data clean, scrub it, and then go ahead, transform it, and then analyze it using your method of choice. Okay, honestly, anything using ranges or summaries has already been summarized for you. You may not be able to look at it the way you need. Anyway, so what were some of the issues with this process? Here's what I would suggest. Excel as complete. This was not even default because I had to put it in the name. And then I got this, which was really too vague to be meaningful. So instead, I did end up with this great chart, and it was very helpful. But if you take a look, it's 5 clicks to get to that chart if you know what to do. I had to guess at the bin with 3 times, and there were 2 Google searches involved. So I guess there's a learning curve. I would probably get better with practice, but right, I mean, let's face it, data manipulation can be a little awkward, and you're working around it. So I'm sure people know how to create pivot charts. For myself, when I tried to use pivot charts, I didn't have access to all the charts. And, instead of fighting it, I found it easier to copy it out. And, I create my own workaround. Right? Here's what I'll tell you, folks. If you've got an occasional need for data analysis, like once a year, then you can get away with this. If you only want to stick with time series plots, no problem. Sparklines are great too. Everything else gets to be a little bit more awkward and therefore less likely to be done. And so here's what I'll say. Statistical software, whatever you use, is going to provide that heavy lifting. But do try to use Sparklines at least. If you're stuck with reports and staring at tables and using inspection to determine trends, at least try to throw in some Sparklines to make it a little easier for people to understand. And of course, make sure your data is correct in the first place, or else it's all wasted.